Hi, in this tutorial we're going to talk about zonal operations. We use zonal operations in order to agglomerate data into certain vector-based polygon units. In my previous classes, we've talked about this project that I'm doing with the USDA in order to calculate surfaces or derive surfaces to the nearest good food and the nearest bad food sources, and then we can divide those to get a unitless quotient. So in this tutorial, I've created a surface here that's called drive time to good food in Robeson County. So this is Robeson County in southeastern North Carolina, and I've used the least cost path analysis to derive this surface here. And I have another tutorial that talks about the way that I do that. You can see in this tutorial these darker areas, okay, over here towards kind of the more populated areas where there's more good food sources. They have low values, darker values, which are 1, all the way up to 38. In this thing, I also just assumed every value below the value of 1 was to be 1, and that was for another calculation that we were trying to do. To me, raster surfaces are a representation of continuous phenomena. Now, typically this continuous phenomena could be anything. It could be elevation. It could be typically physical features like elevation, temperature, air pressure, whatever, but it also can be sociologic. So we can look at things like crime rates. In this case right here, if I zoom in close enough, I can see the individual pixel right here. And I believe this is 50 by 50 foot resolution. So I can just click on this little I button right here, and it'll tell me the drive time, travel time to the nearest good food source represented by green points. And you can see it varies continuously across space to create this surface here. Now this is really good, and it's pretty neat because it's continuous. But when I start to compare this to some type of data where I want to look at the average drive time for this particular pixel versus median household income or population density or any of these other things, we don't have data at the pixel level. That's a big challenge. We can do something called rasterization of our vector data right here and then combine those, but you're going to be working with a lot of data points. Now, you can see I've opened up a Robeson block groups. If I right mouse click and open my attribute table, you can see it's got an ID, a population density, median household income, per capita income, a percentage of people who, percentage of households that receive public assistance, percentage of people who live below the poverty level, all these different things here. What I want to do is find the average drive time to each of these individual block groups. Okay, now these aren't going to be perfect surfaces or these aren't going to be perfect calculations because you can look at the odd shapes of some of these. Some of these are larger, some of these are smaller. But the one thing about each of these block groups is that I know the population in there. I know the median household income. I know the average, the average income. I know the percentage of people who live below the poverty line. And if I start to break these down into squares, which don't have that spatial bias because of the size and shapes attached to them, I might have to do some type of, prorating or interpolation to figure out these values. So in many instances, especially when I'm doing this kind of social science where I need to group or I need to compare these, I can start to group these by these Robeson block groups. And then I can start to look at the median household income where it's low. Maybe there's a relationship between income and proximity to food sources. Okay, in this case, good food sources, or in some cases, my derived food sources. So I'll show this example right here. In the Spatial Analyst Toolbox, I've got a number of sub-toolboxes. I've got Zonal Statistics, and Zonal Table. I've run Zonal Statistics before, and basically all that returns is a new raster surface where we create the mean, or the median, or the variety, or any of these other things by these individual units here. I'm going to give myself a little bit more flexibility, and I'm going to have to do one other thing after this, but this is called Zonal Statistics by Table. So I'm going to double click on this right here. I'm going to move it over. Okay, my input zone data. So I'm going to group it by zone. In this case, it's only asking for one of two different vector groups here. Okay, so it's either good food, and these are points, which is going to be useless in this case, or block groups. We're going to identify by the ID. The ID in this case is going to be the FIPS code. If you saw when I opened up my raster, if you saw when I opened up my attribute table, and my raster value is going to be my drive time to good. So basically what I'm going to do is just average all the pixels within each of that block group, and I'm going to take all of these different statistics. So you can see all the things that I can do here: mean, maximum, minimum, range, standard deviation, min, max, mean, standard deviation. So I'm going to collect all of these different metrics right here for this particular calculation. Also, for the output table, I'm going to save it in the default output table, but if you want to save it somewhere special, make sure you click on the folder and navigate back to the folder you're looking to save it in. Okay, this is very important right here. And when I'm set, I'm just going to click OK. Now remember, this is going to run it as a table here. Okay, and you can see the zonal statistics, and basically what it's doing here is calculating for this particular block group right here. It's calculating the min, the max, the mean, the standard deviation. And when I open up this attribute table, you're going to see there's 88 of these block groups here. Okay? If I open up the attribute right here, you're going to see there's 88 block groups. For these zonal operations, for this long FIPS code, it's got an area, it's got a min. This is the max. This is the range, just the high minus the low. This is the mean. This is the standard deviation, and this is the sum. So some of these are going to be useful, some of these will be useless. In this case here, I'm going to look at the mean. So all it did for this particular block group right here, it just literally went through and averaged every single 50 by 50 pixel and popped it into here, and then did this for all 88 block groups, in addition to looking at the min, the max, the range, the standard deviation, the sum, and the area, in which this would be in square feet, and it counted the number within it. Okay? So this is very powerful. Now, the question is, how do I make a map out of this? Okay? I've got an ID here. I've got an ID here. These are the FIPS code. These are unique IDs. So I can basically run a spatial join between, run a tabular join between the two. So I can right mouse click, join, click on my ID as my source, as my destination. I can validate the join if I really wanted to here. Tells me that 88 out of 88 matched. Okay, and now when I move over here, here's my GIS data layer, but now look what I have here. I've got a count, I've got an area, but I have a min, a max, a range, a mean, a standard deviation, a sum that I can map here. And if I were to double click, watch what I can do. I can look at categories. Okay, under my value, now I can look at my mean. I can look at my classify. I can look at the spatial distribution of these. Some of these are really close, and then from there we have a nice normal distribution for the most part. I can click OK. So now we can see the areas that were the average drive time using my raster-based techniques. Okay. Using my raster-based techniques, these darker areas have the highest average drive time to good food. These lighter areas have the lowest average drive time to good food. And now if I open this up, I can, when export this table, I can start to look at a relationship between per capita income and my mean. I can start to look at a relationship between the average number of vehicles, whether it's urban or rural. I had something called food balance that I'll calculate later. The median age, population density. Okay, and for my classes, especially my raster GIS class and some of the problem sets I give, I don't look particularly for these united measures. I look for unitless measures. So you might have to derive the good divided by the bad and then group these. Okay, and these metrics are really going to be teased out. So I can make a spatial map right here relatively easily. I can double click, look at the standard deviation. Okay. So I can look at the standard deviation to see how much these vary here. So you can see in these particular areas right here, they vary highly between your distance to the, how close it is to the nearest versus how far it is. Okay? And you can kind of see, to me, it looks like some of this might have to do with the actual shapes. But to me, I always find it amazing how all this information is somehow spatially related. Okay. I look at the max right here. I can do the same exact thing here. We've got our max right here. Okay, and this is, this is over towards southeastern as we get down towards Big Swamp, Bladen County, this way here, up towards Fayetteville over here. So this is in Robeson County right here. Here's your big population. I think this is Pembroke right here. Okay. So the main thing that I really want to focus on is using these zonal operations. Now let me go back to my mean right here, and in my classes I'll have you make a map out of this. But from here, now I can start to make comparisons. So I can click on my little I button right here, and for this particular block group, it's got an ID, it's got an age, it's got a population. But as we go further down, when I look at my join, okay, and that exported table, that also has the average drive time to good. It could have the average drive time to bad. It could have a food balance or any of these other things that we look at. So to me, zonal statistics as table is a powerful operation because at some level we need to agglomerate raster data, and this is a means by which we can do it using units like block groups or tracts or counties or zip codes that we have data that's collected by the census. Otherwise, we'll have to kind of smush this data or prorate it if we're looking at pixel level analysis. So this gives our capabilities in order to look at data that can be compared with data that we've already collected and gone through the trouble of collecting.